Kwa hiyo na video lazima nikwambie.
Haina shida.
So, hello students. I hope you are keeping safe at home. Remember everything that you have to do. Make sure you sanitize. After you sanitize, make sure you wear your mask. Keep the social distance. And if there is no need of going out, stay home because that's where you're going to be safe. Otherwise, together we shall overcome. Welcome to our lesson of today, whereby I'm going to continue from where we stopped last time. Remember, last month we were discussing about the longitude and latitude. We were through. Then I introduced you to our chapter number 8, which is concerning the area and approximation. And I say there are different ways of approximating the area of a given object. Remember I told you that you have 4 techniques. You have the counting technique. You remember? The counting technique number 1. Then number 2 you have the trapezium rule. From the trapezium rule you have the mid-ordinate. Those are the 3 of them. Number 3, mid-ordinate. From the mid-ordinate you have the integration method. So in this topic of ours, we are going to deal with these 3 of them, because this one I'm going to teach you the next topic when we are going to be teaching about the calculus. So for the time being, we have discussed this one counting, the counting method. Whereby we say this one is used when you are determining the area of irregular. We have the regular object, but we say you have to have the irregular object and then you count the number of the full squares. Then from there plus the half number of the squares that are not full, so that you can be able to get your area. Remember I said this one is just an approximation. So that number 1 is concerning about the object that is having an irregular shape. You make sure that you trace it on a paper of the square of 1 centimeter, and then from there you count the boxes which are full. Then the other one which are done partially, you count them, but you divide them by 2. So when you sum them, they're going to give you an approximation area of that irregular object. But now I want us to emphasize with these 2. Number 2, which are being tested, mostly in our exam that you're going to be doing. So I want to today we focus on number 2, which is known as the trapezium rule. So the trapezium rule, that is going to be my main target in this topic, in today's lesson. So what are the objectives that you're supposed to be able to know? So by the end of this topic, I want you to be able to know how to approximate that area of an irregular shape using the trapezium rule. So remember the way we agreed on the trapezium rule before I give you an example. We say that this rule need to be able, don't worry about maybe mastering it, but we said it's just there. In our mathematical table, just remind you, area is equals to a half. We have the h, then we have the first bracket, that is y0 plus yn, then plus what? Plus now 2, y1 plus y2 plus y3 plus yn minus 1, and then you put a bigger bracket there. So that's what we say, that these are the length of the trapezium that you're going to be using. Remember in Form 1 we talked about the area of the trapezium. The area of the trapezium being a half h a plus b. Whereby we say these a and b are the length of the trapezium. Then this one is the height. So in our trapezium rule, this is going to be the width of that trapezium, which is going to be, considering that the width, which is supposed to be the uniform, Then these one are going to be the first height, the trapezium that you're using, which you're going to be having. Then this one is going to be the last one. Then the other height which are in between are the one that you're going to multiply by 2. The first one and the last one are not multiplied by 2, but the others are going to be multiplied by 2. So this formula is there in the mathematical table. So our case is to be able to apply it when we are having a question of that nature. So let me show you the way the question is going to be framed so that you see what you're going to be doing. So that's the question which you're given there, and then you're told that a car is starting from the rest and its velocity is measured every second. For how many seconds? For the 6 seconds. So you can see that is the table that is given there. You have the time, then you have now the velocity. So meaning, you need to be able to use the trapezium. So that is the question that the way is using there. So let's see the concept that you're supposed to emphasize on it. So you're told you use the trapezium rule. That is the condition. In an exam, will be specifying out of the 4, I'll be telling you what to use. Remember, if I tell you to use the trapezium and you decide to use the mid-ordinate or decide to use the integration, then you cannot be awarded. So you have to stick to what you have been told. So in this case, you're told to use the trapezium to calculate the distance traveled between time t1 and then when t is equals to 6. So meaning the t1 is going to be our y not there because you're not considering from t is equals to 0, but you're considering when the t is 1 up to where t is going to be equal to 6. That is another condition that you're supposed to be able to know. Remember in our table, the time we're learning from 0 up to what? Up to 6. But now we are telling you to calculate the distance traveled between t is equals to 1 and then t is equals to 6. Remember that we say that in the case of the velocity time graph, if you need to be able to calculate the area that is covered by the motor vehicle, you need to be able to calculate the area under the graph. So my first and B is to be able to emphasize on what you're talking about. The area under the velocity time graph, that's the NB. The area under the velocity time graph represents the distance covered between the given times. So for you to be able to come up with the area under the graph, once you sketch it, you can be able to calculate it. Then to find the required displacement, we find the area of the region bounded by the graph t is equals to 1 and then t is equals to 6. So this is what I'm saying. If you try to sketch the information of the table we are given there, you can be able to see what you're talking about from there. Let me go back to the table. You can see the table is telling us you consider a velocity time graph. So in this case you have this icon there, and then this one you have this one. So this one is the time. Time, and you're told the time in seconds. Then you have velocity. This velocity is given in what? Meters per second. We have the time 0, then you have 1, you have 2, you have 3, you have 4, 5, and then you have 6. Then you can see we are told when time is equals to 0, then the velocity is also equal to 0. When it's equals to 1, you can see we are saying our velocity is going to be equal to what? It's going to be equal to 12. Yeah. Is equal to be equal to, when t is 1, the velocity is 12. So here you have 12. Then again when t is equals to 2, ours is 24. So 2, maybe up to there is 24. 24. And then again, when it is 3, you have 35. There is 35. Then from there, you have when it is 4. You can see 4, 41. Yeah, so this one, we're just starting to come up with that A. Then from there we have, when it is 5, you can see 5 here, 20 is what? 45. That's up there, 45. And then finally, when it is 6, we are told it's 47. 47. Then this is your coverage is starting. So they are telling us to calculate the area that is going to be covered there in our case. We are told that you calculate the area that is covered when t is equals to 1 up to where t is equals to 6. So if I try to join this line, this is what I'm calling my y1, y2 there, y3, then our y4 there, and then our y5, and then you have our y6. What is the reason we are not considering our y0? What is our y0? This one is our what? This is our yn. Okay? Then this is our y1. This is our y2. Then this is our y3. Then this is y4. And this is y5. And then this is our y6, which is going to be our yn. So in this case, when you're told to be able to use the trapezium rule, that's the concept that you're talking about. So you're told not to start when t is equals to 0, but when t is equals to 1. So you should be very careful of that. So it is when from t is equals to 1. This is the region, the area that we need to be able to cover from here up to there. This one, from there up to there. So you're not interested with this part. This part is not included. And that is the trick when you come during the exam, you need to be able to know what you're talking about. So that is a sketch there that I've done for you. I don't know whether it is clear there in my notes, but you can be able to see it on the board. So, in the case of the solution, you can see what you're talking about in the case of the solution. So, divide the area required into 5 trapezium. Into 5 trapezium, each with 1 unit, using the trapezium rule. So these are the 5 trapezia we are using, we are calling them. This is number 1, this is number 2, this is number 3, number 4, and then that is number 5. That's where they are. So then from there you can be able to see, using our formula, our area, and then we are talking about the uniform length. Remember from here, this is our H. This is the width I was talking about. So that is the H, which must be uniform to all of them. It must be uniform. I hope you are getting that idea there. So that one must be uniform. Then if it is uniform, then we substitute our formula, which I said is then the mathematical table. So our area is going to be given by half, then H. This time, our y0 is not going to be a y0 because we are not considering this y0. So we're going to start from here. So this one is going to be y1 plus the last one. The last one is our y6. So y6, then plus 2. The other one from y2 plus y3 plus y4 up plus y5. Then from there, you have to put everything in the bigger bracket. So this word is there, this word is here. H is there from y1 up to y6. Then in our next case, substitute this one. What is y1? You come to our y1 here. The uniform is 1. So this is going to be half multiplied by 1, the bigger bracket. Our y1 we have agreed is 12. Then our last one is 47. Then plus 2. Our y2, you can see is 24 plus 35 plus 41 plus 45. So that is the case where we are having their substitution, you can see. That's the case we are having there for the substitution. You are substituting all those